So why does it take 5 days to get to the moon? And this is one of the faster direct transits. Now, the escape velocity from the Earth is about 40,000 kilometers per hour, or 25,000 miles per hour. So the journey is about 10 times that distance, 400,000 kilometers, or 250,000 miles. So you divide the distance by the speed, you get 10 hours, right? Wrong. It takes 5 days. Now, why is that? A large mass like the Earth distorts the space around it. It creates what we describe and visualize, as you can see above, as a gravity well. And what that means is that you need to be moving really quickly to be able to get out of this kind of valley. Now, a space rocket does all its translunar injection very, very quickly. So it's like a car which accelerates really quick and then has to coast to the top of the hill. So an easy way to understand gravity wells, or Newton's law of gravitation, the larger the mass of a planet or moon, the deeper the gravity well. And what we have is a rocket or moving away from Earth. It's using its kinetic energy, which is based on velocity squared, and converting it into gravitational potential energy. Now, the further you move away, the less steep this gravity well gets. But you get to a point which eventually the Earth's gravitational field strength, or gravity well, is going to just about equal the moon's. It's about 8/9 of the way to the moon. Now, once you go over this point, now the moon's gravitational well, or gravitational field strength, is greater than the Earth's, and you enter the moon's sphere of influence. And therefore, the spacecraft will literally accelerate towards the moon. It really depends on its trajectory. Perhaps a very important thing is to recognize that if the Earth is a relative fixed point, the moon is orbiting around it. So when you launch to where the moon will be. So here's the translunar injection. Now, after the first day, it moves the furthest distance in one day, because the fastest speed is at translunar injection. Now, each day it progressively gets slower and slower, so the distance moved is less and less and less. So we don't actually launch straight to the moon. We launch in an elliptical orbit which just about coincides with the moon's orbital distance. And it starts at around about 40,000 kilometers per hour, and it ends up in tens or maybe 100 or so kilometers per hour. And this is the reason why this approach takes 5 days. It can be done a little bit quicker, but 5 days seems to be common. That was true